Hi, in this video we're going to look at something called a Boolean controlled loop. And it's going to help me fix up some code here that I think is a little bit ugly. So what I've got here is some code that's generating random numbers. It's going to generate one random number from 1 to 20 to begin. I have a count variable set to 0. Then I've got a loop that keeps executing while the number that's generated is not a 7, and it's also not an 11, and my count variable is less than 10. In the loop, I'll print out whatever number I've generated. I'll increase my count variable by 1, and then I generate a brand new random number. Now you'll notice that I'm doing this code twice here, and I have to do that because, well, if I don't generate a random number, then the random number is not going to be initialized, so this would be an error. If I picked any other random number to assign it to, well, then it's not an error, but now it's going to print out that number and increase my count, and I haven't generated a random number yet, and so that's bad. So I'm kind of stuck with this command. And then if I don't do this command, the random number will never change. So I'm kind of stuck having to do both of those. Another issue is this while condition is kind of long. It's very horizontal. And the more cases you have here, you might have a very long while signature, which is also a problem. So I'm going to fix this by introducing something called a Boolean controlled loop. And instead of making these other variables to start, I'm actually going to make a Boolean variable called done, which I'll assign the value to be false. And then I'm going to make a loop that says while I'm not done, do some stuff. Well, what's that stuff? Well, one, I'm supposed to generate a random number. So I'll do that again. You'll notice I'm declaring this variable in the loop this time. It's just going to be recreated. And then I'm going to write some cases here. So one of the cases would be if the random number is 7, then I could set done to be true. I can add another case here. If the random number is 11, then I can also set done to be true. Now the next case I need another variable that's going to be accumulating, so I need to do this before the loop. And that's going to need to check if the count variable is bigger than 10 or equal to. And if that's the case, then done will be true. And then finally I have my else case. And what that's going to do is say, well, I've got a number, so I need to print it out, and I need to increase the count. And my claim is that this will do the exact same thing as the code above. So the way this works is I have a done variable that's set to be false. I say while I have not changed the done variable to be true, then I'm going to go through here and generate a random number, make sure that random number is okay, make sure that I haven't generated too many numbers, and if that's the case, go ahead and do the logic that I want. And so I'll run it just to test it, and amazingly it stopped right away, which means I either generated a 7 or, oops, that should be 11. Let's try it again. There we go. This time it ran a bunch of times. 16, 12, 14, 5, and 17 are generated. And the only way it would have stopped is either the next number generated was a 7 or 11. So you may or may not like this. There are some other ways that we could write this. I could combine these two cases into one. And maybe you'll think that's clear. Either way, this is another way to organize your logic in a loop. And so that way you can kind of break out all the conditions that were in the while signature into two separate ones or three separate ones. You don't have to use this in many cases. It's handy when you have very complex conditions on which your loop will terminate. So here it's based on both the random numbers that are generated as well as a count variable. So the more complex things get, the more likely you'll want to use a Boolean controlled loop. But if you don't think that this is something that you like to use, there's almost not a case where you would have to use it. Additionally, using words like break and continue, sometimes you can get the same functionality without using a Boolean controlled loop. So the choice to use this is kind of up to you. It's going to be important though that you can read this, because many times I will write code like this, or on the AP test you may see a Boolean controlled loop as well. So once again, what we did is we made our loop control statement here be dependent on a Boolean variable, and then in the loop body we wrote code that would determine whether or not the loop should end, and we just switched the Boolean value to be true if we wanted the loop to end, and if we didn't switch it, then it would keep executing this statement inside here. So hopefully that made some sense.